Okay. So like I said, I'm Max, and together with Damian and Maciej, we're part of GANżolna. So let's get to the task we've solved. First, let's talk about the image classification task. Of course, here's the traditional ML roadmap. Load the data, train, validate, and test, but we did some cool stuff that I want to tell you about in this presentation. First, we do extensive data augmentation. So, of course, we resize the images first, then we do some random cutouts, so our model will not overfit as much. Sometimes we add some Gaussian blur, or we flip, or do some affine transformations on the image, and do some stuff with color. As the base network, we've chosen EfficientNet v2. We've also tried other efficient nets, ResNets, and others, but this one worked the best. Okay. When training the model, we used binary cross entropy. We also tried dice loss, but it didn't perform as well. We also used the Adam W optimizer, which is an improvement of the Adam optimizer. Also experimentally, we've chosen that it works best for us. Also standard cosine annealing of the learning rate. And we also do, this is a very neat trick. We allow the optimizer to look ahead a little bit, which makes the model able to backtrack when it finds itself in a optimization space when it is not improving so much. So it can just roll back a few steps, a lot of steps to a place where more optimization can be done. Of course, since this is a multi-label classification task, we want to adjust the thresholds, and we find we approximate the optimum by doing a linear search over possible values of the thresholds, and we calculate the threshold for each class. Now, before prediction, we also do test time augmentation, which means that instead of predicting labels for one image, we augment this image n times, and we produce n sets of labels, and then we average those labels, so the predictions are even better than if we just predict it on one image without any tinkering. And also, to bump up the score even further, we use pseudo labeling, which basically means that when you predict the first time on your test set, you assign those labels to the images and you feed them back into your model. So basically your test set becomes your training set, and you can train it for a few more epochs. And because the data is augmented, the model doesn't overfit at all. Okay, so now let's talk about the audio and video task. For the video pipeline, we clip the video to max length and then split it into 1 second keyframes. And then we just run the classifier on each keyframe and aggregate the results. For our audio pipeline, we run a pre-trained speech-to-text model and then scan the text for labels or synonyms. So we do this in a kind of smarter way. So, for example, compare the first few letters. So this is a kind of a substitute for stemming or lemmatization, because we didn't do this. And then we aggregate the results. Now the result is a pretty minimalist application. You basically select a file, and then it uploads, and you get a table with each label on the left. And then you get the count that it occurred, and then you can see the percent percentage, we could also draw a histogram, and then you have all the timestamps where our model thinks that this label occurred. No, that's all. Thanks.
Cool. Thank you, Max. This is great, and hopefully it will help us travel to cool places in Silesia and beyond. Now, we would like to invite Hop BMate